Continue straight from last video where we calculated the external design wind pressures for external pressures minus 1.005 kilopascals. Now we are finding the internal pressures for the roof. Now internal pressures for the roof of lift that we need to find kilonewton per meter, which is internal pressure when all the doors and windows are closed. The equation is same that we use it for external pressures. Only difference is this aerodynamic shape factor C fixed. Now this equation is taken from Australian standard. This equation is from clause 2.4.1 where we have used this equation with the unit pascals. Once we use these equations, we need to calculate the aerodynamic shape factor for internal pressures. That is given in the clause 5.2 A on page number 27. That is the equation for aerodynamic shape factor for internal pressure CPI KCI. Now KC is 1.11 that we done it in the last video. Now we need to find the internal pressure coefficient CPI. We have two tables given to calculate the CPI. That is on page number 30 and page number 31. Couple of page from that one we have a table 5.1a on page number 30 where the buildings are completely enclosed. There is no opening but some permeability is allowed. And table number 5.1b where we have various opening, let's say leeward wind, leeward door, the opening on leeward wall, windward wall, leeward wall, and on the side wall. But here we assume that all the doors are closed and windows are closed, so we are going to use table number 5.1a to calculate CPI. Now in this case we have all the walls are permeable, so CPI equal to minus 0.3 and 0, so all walls are permeable. In that case CPI value is minus 0.3 and 0, but we are going to take most positive value, which is between minus 0.3 and 0. We are taking 0. Once you find the CPI, we can find the aerodynamic shape factors by substituting the value 0 and KC1, so that is 0. Use this design to calculate design wind pressure. We can use this equation, substitute all the values, but the C fig I, which is equal to, so that is C fig I, which is equal to 0, so the pressure is 0, internal pressure is 0. So back to our last discussions where we have calculated the external pressures and we like to calculate net pressure. So external pressures take away internal pressure is the net pressures. We substitute external pressures 1.0 kilopascals minus 0, so that is given minus 1 kilopascals. Now we are interested to find the roof of lift that is given in the questions, that we need to find the load in kilonewton per meter. So load in kilonewton per meter, so highly loaded portals. So in that case we're going to convert pressures into kilonewtons. The equation is UDL kilonewton equal to pressure times perpendicular length, so 1 times 3.2 meters. So that is given in the question 3.2 meters. How it looks like in the picture. So roof has a pressures here and we have a portal rafter or portal frame here. So if the pressure is applying on here and if I want to find the UDL load, so we need to get the perpendicular length, which is 3.2 meters between distance between two rafters. So that is give us 2.2 kilonewton per meter. So that is your answers for the questions of net of lift load per meters for the ultimate load of highly loaded portals. Thank you.